Hey everyone, welcome to episode 5 of the MicaSense podcast. This is your host, Drew. I'm here with my co-host, Steven. Steven, how are things going with you this early Friday morning in Seattle?
Yeah, thanks so much, Drew. Yeah, I've just been doing the usual testing and support stuff over at MicaSense. Nothing real new on my end. What's new on your end, Drew?
Well, we just had this acquisition happen. So Ag Eagle Aerial Systems just purchased MicaSense. Some of you people listening probably saw the press release. So it's a pretty exciting move. We're looking forward to what's in store for the future of MicaSense. But today we have a special guest, Ruud Knoops from Atmos UAV. So Atmos is one of our strong OEM partners. They have a vertical takeoff and landing drone. It's a very unique system. We're going to hear a little bit more about that today. Ruud, thank you for joining the call.
Yeah, no worries. Looking forward to it, definitely. First of all, congratulations also on the acquisition. Definitely.
Appreciate that. In 2012 and 2013, you were part of this group called Team Atmos, and then of course, June 2013, you're part of Atmos UAV. So, how does that break down? What does that look like? What was the process for
so
getting
indeed,
this company
if you
started?
go all the way back to 2012, 2013, that is actually before it was a company. Here in the Netherlands, if you're on university, they have a lot of these kind of teams, they call it. So Team Atmos was one of the things that we founded. But it's actually a way of putting the knowledge that you learn during university into real practical things of applications. And because I studied at Delft University of Technology in aerospace, so what I wanted to do is, except for only doing theoretical things, I also wanted to apply my theoretical knowledge to like a real practical use or like a real, like using it instead of like doing it on the paper, all the calculations, like really use it for something in the real world. And back then, we actually started the Team Atmos, which had the goal to join the UAV Forge Challenge, it was called back then. And the UAV Forge Challenge, that was a competition which was a collaboration between DARPA and SSC Atlantic, where they wanted to build a drone. Back then, it was for military surveillance purposes. Because if you recall to 2012, that was the year where drones were almost only used for military applications. And over the years, and especially now, that's the other way around. But actually, that was the first time that we went from theoretical knowledge to really practical. In the end, we became third on that event from more than 120 teams worldwide.
Wow.
So that was really something that we are really proud on back then, because we were just 10 students building this drone actually. And actually that Team Atmos and becoming third in that challenge, we actually looked to each other and we thought like, hey, if we can beat so many teams around the world in this challenge, maybe we can do more with it than just leave it where it is. We want to see if there was really a potential with the technology that we have developed back then commercially, while also finishing our degrees.
So DARPA is the Defense Advanced Research Projects Agency in the U.S. And I know in the past they've done like autonomous vehicle competitions where they say like you have to go from like, through the desert from like, Northern California to Las Vegas or something with a autonomous vehicle. And this was 10, 15, 20 years ago. And so this was a similar competition, but with UAVs.
Yeah, focused on UAVs.
And what was the outcome or the goal?
The goal was actually, it is very similar to what we do now. Is you got a very small space where you needed to take off and land your drone, and you needed to fly for, I believe it was 3 miles back then. Then you need to do an observation, return back, and then land again at the same spot. So that was the original competition challenge, but we wanted to even push ourselves further, and we would say, okay, we're going to take off and land from a small space, but we want to be able to fly 30 miles. So that is how we actually wanted to push ourselves in order to go even beyond what the competition wanted us to do. Because from a technical point of view, if you want to take off and land somewhere, you want to fly 3 miles, I mean, a standard multi-rotor, they can just do it. But by really adding up to, or like really pushing yourself to be able to fly 30 miles, well, that is a very different scope, because for that you need a fixed wing, and a fixed wing then again cannot take off and land in a small area. So then you got really like this crossroad where you need to try and combine both of them actually, which is what even resulted now in the product that we have.
Yeah, the Marlin. So how similar is today's Marlin drone to the one that you guys produced at UAV Forge?
I think the biggest difference actually from a usage point of view is that back then when we were building the prototype back then, and it wasn't Marlin yet, we really had a lot of issues with wind stability because of its design back then, which is typical for tail sitters. And it's actually from that experience that we had earlier on that we knew that we needed to do something about it. And that is actually what we have in our current design, is that we got like different kind of wings with motors that can rotate, which actually allows us to get like a very high wind resistance. So I think those are the two biggest differences. And it's a little bit bigger.
Yeah, tail sitter. I like that term. I think I'm a tail sitter, actually.
We're all, as long as we're not sleeping, we're probably all a tail sitter.
If we're working at a desk, we're tail sitters.
Yeah, definitely.
Steven, were you going to say something?
No,
You were thinking about the tail sitting?
Yeah, I was about to look up what that, if that's an actual word.
No, I think it makes sense.
A tail sitter aircraft, actually, that is where it comes from, is actually that the pilot is not in like his natural position when it would be flying, and it is like sitting on his bum. But yeah, that's actually where it comes from. But that is also something which is very interesting. In the course of years, we had so many different kind of terms for this kind of drone that we built, because back then it was called a hybrid drone, because it was a hybrid between a fixed wing and a helicopter. Mm-hmm. Then at some point it became a tail sitter, which was an older term because hybrid was used more and more for like cars, like the hybrid cars with gasoline and electrical, the combination. So then people did not really understand what we were doing, because you also got hybrid drones which do that with the and petrol, of course. And then they went to like a tail sitter, and then they went to like the VTOL plus fixed wing.
If someone came up to you and said, like, why is Marlin unique? I mean, what's the advantage to Marlin? I mean, you mentioned like close quarters for landing and takeoff. Is there anything else that is worth highlighting?
The biggest difference or the biggest advantage of Marlin is that it goes further than a system. The system goes further than the drone itself. I think also everything which comes next to it, next to the flying, because the flying is actually only half of the work. So all the supporting equipment and software needed to get your results. I think that is a big plus. The wind resistance that I mentioned is something that we've been working with this kind of drones since 2012. And wind was first the enemy. Now it is more like a friend for us. So the wind resistance is really something which makes it unique. And of course, because of the drone being a VTOL fixed wing, it is the takeoff, which is vertical, which is easy, but the long range and the long endurance really allows it to cover large areas in a fast time.
Yeah, I was actually having a call with a guy, a researcher at, I think, University of Columbia, like maybe a year ago, and he wanted to do some mapping of coastland, but he was going to be taking off and landing from a ship, and he was looking at the specs of the Marlin, and he was looking at some other drones as well, and he thought that the Marlin was really the only drone that would actually be able to take off and land on that moving, or like basically on that ship where you've got tons of wind, you've got waves knocking the boat around. So I thought that was impressive.
Definitely. I mean, because then you got the wind of course, but especially like taking off and landing on a ship is also, again, like the close or just a small footprint that you have available in order to take off.
So You guys started in 2013. It's 2021 now. What you started with? Were there 3 co-founders or 4 co-founders?
Well, and indeed, we were with all of the founders that are still active were also back then active. But I think what the most important thing that happened back then, or if you look at 2013, drones using for commercial usages, was like really in its starting. While I would even say that the starting of the commercial usage of drones for mapping is even a couple of years later. So what we actually did back then is started a company because we wanted to file for a patent. So that's actually the reason why we founded the company back then, to file a patent on the company. And in the meantime, we were actually further developing, because at that moment we were only working for like 6 months on this new drone. And to go even further, back then you didn't have like this autopilot which even enabled drones to rotate midair to go and flying. So we had to develop our own autopilot, our own software. All of it had to be in-house developed, and we were very proud of ourselves that we could accomplish it actually in only 6 to 8 months back then. So that was really a big improvement. So from there on, we had like a prototype, and the search for product market fit actually began.
When was the first, maybe like the first time you guys actually sold an aircraft?
The first drone that we really sold for like this mapping purposes with the Marlin, how it looks right now, 3 years ago, I believe. And that was actually in order to go and map a remote island. So immediately it was also a very interesting, very challenging experience back then.
Yeah, I think I saw like a blog post or a marketing story on that on your website.
Yeah, indeed. It was the island of the Seychelles, because it is the Seychelles is an island which actually houses a certain tree. Well, back then there were only 3 left on the entire planet.
Wow.
And they were all situated on that island. So that was really into environmental safety, because they wanted to get an overview of, or an up-to-date map of that island, because they have only found a couple of those 3, but that doesn't mean there are more or less on the island, because the island is it is a big wilderness. Going from one end to the other end on the island took days, while it was only a couple of kilometers. But you could just run into a cliff at one point, which you could see on the Google Maps or whatever, because it was a very narrow cliff. So it was very important for them to get a updated map on it.
And was that successful in finding any more trees?
I don't believe that they found more trees, because what they wanted to do back then was use RGB. They wanted to use RGB data in order to see if they could find the same canopy, because it had a typical canopy on other places on the island. I think back then with a multispectral camera, they would have had more success by really finding it by looking at the data itself, because then they could probably do some better analysis on that. But back then, no.
So there's some advantages to using multispectral, is what you're saying.
Yeah.
like the Altum. So you guys
enter MicaSense.
So you guys integrate with the Altum and the Red Edge MX.
Yeah, but that was later. That was later.
Yeah. So how has that been working? Have you had any good use cases you've seen with those integrations?
Yeah. They go from very interesting to very strange ones, actually, very odd ones. I think the most odd one is to see if they can find bear dens inside forest with the MicaSense, with the and that goes into they don't know exactly yet how they will do it, but they imagine, or they think the combination of the thermal camera will allow them to find bear dens, because this is an area where there is a lot of activity by people. It is a mining area, but people sometimes just when they expand, they first need to find the perimeter, and they need to measure where is the perimeter, and they need to set the poles, because they cannot go any further. But that is typically in an area with a lot of trees, and then they can just run into a bear or a bear den. And that is actually what they try to avoid by first using the drones to fly over it, like a preliminary check if there are any bear dens, and then they go and set out the perimeter. So that is a very odd one.
Yeah, definitely.
I didn't thought about. The other one is actually a project which was lost. No, not the in the summer. And what they do is actually with the, I believe it is called the tundras in Mongolia. They're actually using the like the big grasslands. They are trying to train satellite data with high resolution imagery from the Altum with the Marlin. So what they do is they get, like, because Mongolia is so huge, they have satellite imagery from the entire country, and what they then want to do is they want to go to, or what they did, they went into places where there is like a lot of grass and a lot of dead grass, because in Mongolia there are a lot of nomads, so they travel around with like their entire, like the family, but also all the bees.
Wow. Yeah.
Kind of they still wander around, and it happens sometimes that they go into an area where there are not that many fresh grass, which actually is a problem for them, because that means that their horses and everything and their cattle that they take with them, they cannot eat anymore, which is a big issue for them. And with the current environment changing, and it's only getting hotter, the chances are really higher that they go into like a certain area, or even a big area where there is no food for their cattle and for the animals. So that's a big issue. So they want to actually take the multispectral imagery from different areas where they know that it's good, it's not good, and then see if they can train their satellite imagery, which is of course much lower resolution, to spot for trends in order to use satellite imagery to set out routes which are actually good or are safe actually for these nomads to travel.
Interesting.
Wow.
So that must be like like a state funded thing for their citizens, sort of, or are the nomads themselves actually doing the flights and the analysis?
No. So it's a university in Germany. So I think it is a UA subsidy,
Gotcha.
which actually helps the nomads actually in Mongolia. So I believe that is the construction that they have. So it's a European university that's actually doing these flights.
Yeah, I was talking to James about that, and I think we were really hoping to get some of that data, but I don't think he's gotten back. The customer hasn't gotten back to us. That'd be a great marketing story to put together. I think a lot of people would like reading about that.
Yeah.
I mean, the bear dens is interesting as well. I would assume that they're probably just seeing like hot spots. Those bear dens are probably full of heat.
Yeah, that is one thing that they can do, but it could also be because these bear dens, it is just not like a hole in the ground. They also build something in order to do like their the hibernation, I believe it's called in English. So it could be that you can even track that also through the trees, because the trees there are not a lot of leaves on it, so you can pass through it.
Okay.
It could be that you can see the hotspots indeed, or you can see something with the other channels.
Or if you've got a hot spot and a high spot, then there's a pretty good probability there's a bear den there.
Yeah, you can go around that instead of through it.
I like that value proposition, right, Steven? We could sell this system to like every single person who hikes in bear country. You could be like, do you want to get eaten by a bear, or do you want to spend $20,000 or $30,000 on a drone system?
Yeah, you're right. You sell the drone and you'd fly it before your hike.
Before your hike,
and then you can identify a map showing where everything is, and it can even be flying while you're in flight, because it can fly for so long. And while you're hiking, you get a notification that there's maybe a bear nearby. So getting back to the Altum, how exactly is that integrated? Is that using one of our APIs, or is it using an automatic triggering option?
Both of them, so both the Altum and the Red Edge, they're integrating using the API, the autopilot, which is actually connected to the camera and triggers it from there. But that is also important for us because we also link it to our PPK module. So the post-processing kinematics module that we have integrated in our Marlin, in order to get the high absolute accuracy without the use of ground control points.
Oh, that's great. That's definitely something customers ask us about a lot, is PPK. So that's
I can imagine.
really you guys are one of the only integrators who have done that PPK integration. And it seems like it's becoming more and more popular. More and more of our customers are looking for that higher precision from the PPK. So do you include the ground station? And I was kind of poking around on the website last night, and I saw some accessories as part of the drone system. Can you talk to that a little bit?
So what we do indeed, like we sell the entire system as a whole. So you got, of course, like the drone, but also the supporting equipment, such as a backpack where you can put it into, so you can also travel with it even on areas that are not really that accessible. You can just go over there. With it, it also comes with the batteries, battery chargers, and a dongle to get all the data out of it. So it's a complete solution.
Yeah, I think that's good for be good for Steven and the support team to know that, because I think you guys get a lot of questions about PPK. And
yeah, definitely a lot of people want the accuracy in the metadata.
When someone buys a Marlin and they have the RX1 and then they want to get the Altum, is it a simple like throw in a new payload bay, or what's the process for making their drone compatible?
Yeah, so in the nose of Marlin, there is a payload compartment, as we call it, and we call it payload because it is the broadest sense of word you can use. But yeah, all of them are actually cameras. So what you can do is just simply take out one payload module, put in the other payload module, notify the autopilot that the payload module has been changed. Of course, you need to insert the right characteristics, and you're actually to go. And you can use the MicaSense cameras as well.
Okay. Yeah, that's good to know. I want to take a step back a little bit. I just saw some application examples that you listed that sound kind of interesting. So one was wind farm. I mean, these might not necessarily include the Altum or the Red Edge, but
no, indeed, yeah.
What's can you tell us about that?
So that is one of our customers who is building wind farms actually all around the world. So on all remote places. And what they actually do with the Marlin is they use the Marlin actually for a lot of different applications at once. So first of all, when you're going to design a wind farm in a region where there are a lot of like mountains, you actually want to have like a very good 3D model of that area. Because with that, you can actually also modulate the wind and the wind speeds at different positions. Because as you can imagine, when it is, or as you probably have experienced, when it is very windy and you're standing next to a building, at one point of the building, it could feel like wind still. But on the other end of the wind, or the other end of the building, you could be blown away from it. Yeah, because of how the wind works with the environment. So that is also what they do actually with the 3D models that they generate using Marlin. And this is also actually, again, where the wind resistance of our Marlin comes in place, because in these areas, it is typically very windy, because with this wind, they produce their energy, of course. They also, during the building process, use it in order to do equipment tracking. Because these kind of sites, you need to build 20 to 30 windmills at a site. And they're working with a lot of local companies and also people that, of course, need to move the equipment from A to B. And they use this orthophotos in order to see if all the material is on site, for instance, to build windmill 32, and not that it is delivered wrongly at windmill 28, or because they have a very tight schedule on when these big cranes come to each windmill. And if the big crane is there, but not the equipment or not the parts that they need to lift into place, then it's such a waste of money and time. So they also use this to do like a sort of like a forward planning if everything is delivered at the correct area, actually.
Okay. So they must be covering a lot of ground then with the Marlin for those.
Yeah, they can cover like very big areas if they want to do the entire modulation actually of the area. and depending and with the so for that one and for the other one, when they want to see if there is to do like the forward planning, they only need to do like a certain place, of course, where they want to do the forward planning, because they can see if it's there or if it's not there, and otherwise they can use their orthophoto that they create earlier. But these areas, they can go up until like 22 to 20 square kilometers.
And then what's the mud flaps one?
The mud flaps, that is in the Netherlands. So in the north of the Netherlands, there is a area. The tides actually, it is constantly eroding away actually. So here in the Netherlands, we're famous for battling against nature, and especially battling against water taking the land. And this is actually a research on how this erosion is being done at this specific area. It is also an area where during low tide you can just walk 20 kilometers, and then you will be up until your knees in the water, but you can just walk to the other side of the Netherlands. So it's a very thin layer of water, but because constant the tides are working on that area, they want to have an idea of indeed. And they want to get a more detailed update than they have now, because now they use airplanes, like they come over once a year, but they want to be more in control, and they want to have a better resolution on what is going on there. Because if you do this for a year, every 2 months, make an overview of that area, then you can also see how much is eroding away. Because what they want to find out is that the actions that they took to battle the erosion, actually, to go against it, and even to create added layers, so not that it is eroding away, but that it is adding actually, so that the layers become thicker. They want to verify if that is working. So what they do is they actually have like poles planted a little bit inwards. So from the moment that the water washes away, these poles and these nets try and trap actually everything which is washed away.
But kind of works like roots.
The tide comes in. Yeah, the same idea indeed. Yeah.
Gotcha. Stephen, do you have any more questions?
One advantage of MicaSense that we see these days is that since it's made in the United States, a lot of governments and institutions are more likely to buy it because of various trade restrictions these days. Mm-hmm. Is the Marlin made in Europe, and is that an advantage you've seen?
Yeah, definitely. Because at this moment we do all the assembly of Marlin itself, but also, like I mentioned, like the autopilot is something that we've developed ourselves, and a lot of components in it. So at this moment, I think 85%, when not taking into account the payload, is made in Europe.
Okay.
On the long assets.
I feel like we've talked to a lot of fixed wing and VTOL manufacturers, and it really inspires me to use those more, because when we do our testing, we only ever use multi-rotors, but these sound like a lot of fun, and they sound a lot more practical for doing longer flights.
Yeah, my hope for 2021 is we can do more collaborative work with Atmos and similar companies. I think it'd just be cool to do more like in-person demos together and that sort of thing.
I couldn't agree more.
Do you have a favorite book that you can recommend to the audience? Maybe a favorite novel? I'm a big sci-fi fan, so if it's a sci-fi, you get bonus points.
Well, it's not really a book, but it's more like a movie. But I really like the Iron Man. That is something that I really think is very cool. Like the Tony Stark, the Iron Man. I think that's something which I think is very cool from very early on here, because from the moment I had to make a decision in I think it is called high school in the US, you need to make a decision here if you want to go for a technical career or for like a more a general approach. And from that point onward, I was just always into the technical things, and actually it stayed that way. So I really have a weakness for this kind of very sci-fi, like extreme sci-fi, which goes into the technical area.
Okay, well, Ruud, we really appreciate you joining us. I think we covered a lot of good stuff.
Yeah, it was really fun, definitely.
Yeah, thanks so much for joining us.
All right, well, that's all for this episode. Thanks, everyone.
Yeah, stay tuned for the next episode of the MicaSense podcast.